Hi guys, I hope you're good since last video. So this time we're gonna set up a Kubernetes cluster. So let's install some different tools just to set up our VMs. Here we go. Next, we are going to change the host name. So let's call this one controller Creditizens.net. So that will be the control node. We just check if it is applied. Host name, yes. So now we're gonna go into the other node and do the same. So here, that's the same command. Let's just change the name of it, which will be worker 1 or node 1, exec bash, and we check. So the host name has been updated, that's good. Now we get rid of the swaps. So Kubernetes scheduler need to have full access to the RAM, the memory, in order to be able to predict how much memory is going to be used by the pods. So for that we need to get rid of the swaps. And here you see we commented out this line. So we just use this bash command in order to apply this replacement. We do it same here in the node 1, and we keep going in those configurations. We're gonna be working on using the container D. So container D, the configuration, I'm just gonna show you what we just added now. We added the overlay option on the BR net filter. So we need to add those options into the node. So for the moment we're doing the same installations in both. So here now we are ready to install the overlay to activate those options. And here the net filter. So we're setting up the which is going to be handling the networking of our Kubernetes cluster. So we're going to repeat the same here into the controller node. That's good. BR underscore net filter. Now we are just going to be applying the bridge networking. So in the Kubernetes config.conf file, and after we're going to apply it to the sysctl. Okay, now we do the installations for the certificates, the common properties. Now we install also the library. We just curl those different libraries to be ready to install Kubernetes, kubectl, and so we need the Docker one here. We're gonna update. We install container D at the same time. We change the configs to the containerd. So I'm just going to show you here what we changed. We created the configuration file and we added that the system C group equal to true when it was false before. Just let me check that and I'm going to show you. So here we're in the file and I just need to find the line where this configuration has been changed. Here, system C group true. So that's what we changed. As for the plugins of containerd. So that's for the container runtime interface to have access directly to the containerd. Now we activated. We just check, we restart. So everything is good. There's no error message. So we started the container runtime. And we do the same here, control node. So we get the keys. Now we're going to prepare to install Kubernetes. And now install Kubernetes, kubadm, and kubectl. So I mean kubelet, kubadm, and kubectl. And we add the command for the versions. We need the versions to not be updated, to stay the same. And we need to have control into those version updates for the cluster to have the same configurations or to be able to test before migrating, before upgrading. So we put on hold on those versions and we check the versions. Here the kubelet version, we have the Kubernetes 1.27, same for the kubadm 1.27 here, 1.27.3 here. We can also check maybe kubectl. So the version of kubectl. We got it at Git version 1.27. That's good. Which is here. So now we have everything installed. So we're just gonna map those VMs to their hostname with the IP. So we're gonna be going straight to the etc hosts and do this process. So we're gonna sudo nano etc hosts. That's good. And here we're gonna put the IPs and the host names. Let's put the host names. We say node 1, or we say worker, node 1, .creditizens.net, and the other one will be controller. Just gonna copy this and put it in the other VM with the same configurations. That's good. Here we go. And now we can save. So now they will be able to know where each other are, and you'll be able to use the host names instead of the IPs. So we're gonna init the kubeadm cluster. We're just gonna add the option control plane endpoint and use the host name of the controller instead of the IP. So it's gonna be creating here. Just wait a bit. It's not gonna take long. One or 2 minutes. So make sure to see every steps, to not miss any, otherwise your cluster is not gonna work. So I suggest you to watch the video to the end. That's good, we have the certificates, the kubeconfig created, the kubelet service on the control plane. Everything now it's waiting for the control plane is done. We got it. And here in the output, we get the commands to join any worker node or controller. But before that, we need to copy the kubeconfig file to our home directory, and we need to change the permissions on it. So we just copy these 3 lines of codes and we apply them. So we make in a directory, in our home directory, and after we're copying the configurations, and after we change in the permissions on those configurations, and everything happened now in the controller node. So kubeconfig, it's a file that has the certificates. You can see here the cluster certificate, and here the user certificate. Cluster, user, Kubernetes admin. And the client key data. So we're going to check the tokens. Kubernetes token list. So that's the one we had in the output after installing Kubernetes. But let's say you can't retrieve it or you don't know how. That's how you retrieve it. You get the token list, and you can create also new tokens. That's what we're going to do here. Creating this token is going to give us the command to join a new worker node. So kubeadm token create -- print dash only one, not two. Join just one, and join command dash command. Command. Good. And now we get the command to join a worker node. Now the list. See, now we have those two. They're here. That's the new one, and that's the one we had before. I'm just showing you the nodes here. We have only one node, which is not ready, but that's normal. I'm going to show you later on how to make it ready. And after here we have our command. We are in the node 1. Here put sudo, because we need the root permissions to be able to do that. So just in a few seconds, we're able to get that node in the cluster. As you can see here, get nodes shows us the second one, node 1 Creditizens.net. So we in. So after that, we will need to install a network handler. Like I'm gonna choose a Calico. I'm gonna do it later on. But before, I'm just going to show you different configurations. kubectl, get config map. So we're getting the config maps here. We're going to check just kuberbdm configs, because it's important to have inside the record of containerd, because you remember we installed containerd. We're just checking to make sure that containerd is in the config. kubectl edit kube.config, the namespace is kubesystem. What did I do? Ah yes, edit config map here, and we should see C group driver systemd here. So that's good. So that's our container runtime. Okay, that's the show. Okay, so we get containerd to our config map. We don't need to change anything, we just exit. So I tried to install Calico. I found some different YAML files online, but I got some trouble to install it. So now what I'm trying to do is to just reboot the computer and see if it is going to be fixed. If not, I'm going to try to use a Calico file that I had in my library. But normally you go through internet to try to find it. But recently I see that people are having trouble with finding the right Calico YAML file online. Because I read some different comments. And let's just go back to our cluster. We always get the nodes at the beginning. We see they're not ready. Just gonna get it first. And I'm gonna apply this Calico YAML file. That one should work. It's good. Just after we get the nodes. So we have the operator here in the namespaces. Just check the pods. So the pods are pending. So as it doesn't work, now we're going to delete it. So that's the one I found through the documentation. but it didn't work. So we need to delete those resources and try the other one. The Tigera operator also. Let's delete it. Okay. So we're gonna free our cluster. That's here, Calico YAML. Just gonna get rid of the custom resources one, which didn't work. Bye-bye. And now we have our Calico YAML file. We're just gonna apply that one. Okay, everything is deployed. Cluster role binding, daemon set, the services, the config map. We got the namespaces. So everything is in a kube system. So we're gonna get the pods, all namespaces. And here we can see that the pods are creating. So let's use this command, but in a watch mode to see what is happening. So kubectl get pods, namespace, kube system, watch, and now we can see live what is happening, how the Calico pods are deploying. So they're in init stage. Okay. Keep the nodes. Now you see the nodes are ready. So let's follow, for example, this one here. Calico kube controller. Container creating. Later on, it's still creating. And at the end is running. It is not ready yet. And at the end is running. 1. And we have it ready. 8v4pl is not ready, is in initial stage. 2 out of 3. Later on, so it's still in init stage. Just 1 second later, the pod is initializing. After that, the status changed to running, and after that we got it running but ready. 1 out of 1. Let's put it a bit wider to get more information in the IPs. So you can see here the nodes defined by hostname. We have the IPs. This is just a quick look around to see that the cluster is running properly. So you need to stay a little bit more. I have something to show you before the end of the video. Because you want maybe to have more nodes running into your cluster, because here we have only 1 node. So later on I'll be joining another node. So let's check all the deployments. So we have the Calico kube controller on the core DNS. That's for the deployment. The secrets. That's the bootstrap, the normal secrets that we have initially. The config maps. We got the new config map, which is the Calico config, which has been created with the cluster, in the cluster. And after pods. So here for the pods, we have 3 new pods created, corresponding to the Calico pods for the networking. We're gonna create a deployment. So kubectl create deployment, replicas 3, and we're gonna use the image. So here you can put the image of any application that you have on Docker Hub, for example. So deployment name will be Nginx, and the image, the Nginx, the latest. Just gonna put Nginx like that. 2 points and the latest. So I need to add L, kubectl. Good, this is deployed. So now we get the pods. It should be in the default namespace, as I haven't created any, and in a watch mode. At all, there's 2 dashes here. That's good, and it's running. We have our 3 replicas running of Nginx in the default namespace. So what we're gonna use here is the scaling. So to scale it, to have more of those. So kubectl scale replicas to 10. And the deployment /Nginx. And now you see it's creating container after they're running. So we had 3, so it has created 7 more. And you can see some are on the controller and some of the ones are in the node 1. That's why we got rid of the swaps, so that the scheduler can decide where to put those without any conflict with the normal swaps. Okay, so that's all the pods. We have 10 of those. So that was scaling out. We can also scale in. So let's scale in to 2, from 10 to 2. And you see now it's going to be terminating those pods. So he's getting rid of 8 of those. We have 2 pods left. And there's no order, depending on the availability, because you see here, one is edge from 2 minutes 55 and the other one from 130 seconds. So I'm just gonna fast forward and do all the installations in a new node. So we're gonna get rid of the swaps, install containerd, install kubectl, kubeadm, and the kubelet. And now that we have done this installation in a few seconds, thanks to the video editing. So now we're gonna just check the tokens that we have. You can use the same token to join a new node, but I'm just gonna create a new one to join this node. Okay, kubeadm token create dash print dash join dash command. Now we got it. So we just copy it and use sudo in order to raise the permissions in order to join the. Here we have 3. See, now we have 3 tokens. That's the latest one. Now we go into a node number 2. So if you watch the video very thoroughly, you'll see that now before joining I should do something that I haven't done yet. You see, it's not joining. So get nodes, right? So we watch, but it's not joining at all. So I don't know if you could guess, what did we miss? There's one thing that you need to do in order for the nodes to be able to map IPs and host names. That's what we need to do. Okay, so let's do the job. We're gonna go into the etc hosts to do this mapping by adding the new IP of this node, IPA. So this is ending with 148. We're just gonna add it in all the nodes on the controller also. So in order to join the cluster, at least the controller on the node, the one that is joining, need to know each other. Here, just gonna change it to node 2, and here 48. That's good. We copy everything. We're gonna do the same in the controller. This is saved. Okay. Let's add this line. Now we copy all. Just gonna put it in our new node. Let's go to node 2. Sudo nano etc hosts, and we put it in. We save, and now we can join the cluster. Hostname, good. That's the right one. Here we got the right one. Okay. Just gonna find the command, and now you see. Let's just watch. It has joined, but is not ready. So after having joined the Calico node, it's going to be able to create the networking. Just wait a few seconds. So here it's done. Not ready yet. And now it's ready. So it took just 48 seconds to join and to be ready. Ready means that we can deploy application. This node is ready to receive pods. So the scheduler can send pods to this node. In the Calico, you see still initializing the Calico node on this new node. Now is in a running status. and now it's ready. So using the watch command, you can just see what's happening, the different stages. Initialization, pod initialization, running, and after ready. That's good. So let's create a namespace. Let's call it proxy Nginx. And what we are going to do, we're going to deploy an Nginx pod. We're going to scale it and see if it is scheduled. We're going to put the replicas and see if they are scheduled in the new node. So Nginx means kubectl create deployment. We're going to call it Nginx prox. In the namespace, the new namespace that you have created. Now the replica. I'm going to scale it after. Image Nginx latest. So this deployment is created. Now let's scale it. Let's put 12 of those. So for sure, node 2 is going to be scheduled for pods. Deployment, Nginx, prox. Did I miss? And the namespace. So as you created a namespace, you need to mention it. So that's a separate environment. And now we can see with the watch command what's happening. It's creating the controller in node 1. You can see down there the IPs affected. And now it's deploying. It's running on node 2. Perfect. So you've seen how to set up your cluster, how to join a new node, and you need just to struggle a bit and fight to install Calico. Hope you liked this tutorial. See you next time.